Good morning, students. Dear students, today in this video section, we will discuss about numericals for the taught portion. So, let us start with our first numerical. So, students, look for the numerical first, and the numerical says that a motor car starts from rest and accelerates uniformly. There is uniform acceleration for 10 seconds. For 10 seconds, the car accelerates uniformly with a initial velocity of 20 meter per second. After that, car runs at constant speed. Now the acceleration is zero and the car starts running with constant speed, and finally it deaccelerates or retardation takes place and comes to rest by traveling a distance of 40 meters with constant acceleration. The total distance covered by the car is 640 meters. All the three motions, it starts from first phase is it accelerates, then with constant velocity, and after that retardation, and in the whole motion it covers a distance of 640 meters. Find the value of acceleration. You have to find the value of acceleration, retardation, and total time taken. Throughout the motion, for the whole motion, you have to find the value of acceleration, retardation, and total time taken. So let's go for the solution. Look at the solution for this numerical. Solution. Let x1, x2, and x3 be the distances covered in three parts. In first part, the distance covered is x1, in second part is x2, and in third part is x3. For first part of motion, for first part of motion, for first part, since initially it starts for rest, so u is equal to 0, time is given, that is equal to 10 seconds, and velocity, final velocity is 20 meter per second. So by applying the velocity time relationship, v is equal to u plus at, by v is equal to u plus at, so v is equal to 20, u is equal to 0, and acceleration, the value of acceleration we have to calculate, and time is given 10 seconds. From here, acceleration is equal to 2 meter per second square. 2 meter per second square. So x1 is equal to x1s is equal to ut plus half at square. So initial velocity is 0, so u into t, that is equal to 0 plus half into 2, it is calculated, acceleration is 2 calculated, and into 10 square, 10 second. For first it is 10 second. So x1 is equal to 2 to cancel out, and it is equal to 100 meter. x1 is equal to 100 meter. This is the first part of motion. Now for second part of motion. For second part of motion, x1, for second part it is traveling with constant acceleration. So x1 is equal to, you had got 100 meter, and x3 it is given as 40 meter. X3 is given at 40 meter. So x2 100 plus x2 plus 40, it is altogether equal to 640, and from here x2 is equal to 500, x2 is equal to 500 meter, x2 is equal to 500 meter. And since it is uniform acceleration, so distance time time taken to cover the distance, that is 500 meter upon, it is traveling with constant speed 20 meter per second, so it is equal to 25 seconds. So 25 seconds is the required time. T2 is equal to 25 seconds. 25 seconds is the time taken for second part of the motion. Now for third part of the motion. For third part of the motion, for third part of motion, initial speed u is equal to 20 meter per second. It comes to rest, that is v is equal to 0, and x3 is equal to 40 meter. It is already given in the question. So applying v square minus u square is equal to 2as. Final velocity 0 square minus 20 square to 2 acceleration. You have to find that is the retardation, and it is equal to 40 meter. So it is equal to A is equal to minus 400 upon 80 meter per second square, and it is equal to minus 5 meter per second square. So acceleration is equal to minus 5 meter per second square. This is the retardation. This is the retardation is equal to 5 meter per second square. Retardation is equal to 5 meter per second square. So you have calculated all the things which is asked in the question, that is value of acceleration, retardation, and total time taken. Total time taken you had calculated. Now for the next numerical. Now students, dear students, look at this question. This is a very good question, very good numerical, and it is given in the question that the particle moves along x-axis. The movement of the particle is only considered along x-axis or concentrated along x-axis. The position of particle 1 is x is equal to 6t square plus 3t plus 2. That is, position is given in terms of time, so by dx upon dt you can calculate the velocity. Now acceleration of the particle is given by at. Acceleration is the function of time, so from here you can also calculate the velocity by integrating it. And at t is equal to 0, its velocity is given as 20 meter per second. At t is equal to 0, the velocity is given 20 meter per second. So it is asked that what is the time when the velocities of the particle match. You have to find the time when the velocities, both the velocities for particle first and particle second, both the velocities will match, and then you have to find the velocities when they will match. So look at the solution of this question. Good question is here. For first particle x1 is equal to 6t square plus 3t plus 2, and for second particle a2 is equal to minus 8t, v2 is equal to 20 meter per second at t is equal to 0. So first we do our calculation for first particle. And for first particle we are interested to find the velocity. Velocity as the function of time is equal to dx upon dt, or you can say that vt is equal to d upon dt, 6t square plus 3t plus 2, and on differentiating you will get vt is equal to 12t plus 3. This is about the first particle. Now we have to find the velocity for second particle. For second particle you have to find the velocity, and integration of at dt gives the velocity at time, because it is simple that acceleration is equal to dv upon dt. So you can say that a into dt is equal to dv, or integration a dt is equal to integration of dv, or v is equal to integration of a dt. From here you can get a dt is equal to vt. Now here acceleration is known to you, so vt is equal to minus 8t dt, and on integrating you will get the value 8t square upon 2 plus c, 2 4 is 8, that is equal to vt is equal to minus 4t square plus c, but here you have to find the value of constant. So you will check the condition given in the question, and according to question vt is equal to 20 meter per second and t is equal to 0. According to question vt is equal to 20 meter per second at t is equal to 0 second, then you can write here as 20. Here I am writing 20 is equal to t is equal to 0, so put t is equal to 0 here, 0 plus c, or you can write here c is equal to 20. So by the value of constant for this condition you have get the value of constant is equal to 20. So v to t can be written as minus 4t square plus 20, minus 4t square So v1t and v2t you had got. So we have to find the time for which both the velocities v1t and v2t will match. So v1t is equal to v2t, and it implies that v1t is equal to 12t plus 3, and it is equal to minus 4t square plus 20, and from here 4t square plus 12t minus 17 is equal to 0. Now look at here, middle term splitting I think not possible here. You can't do middle term splitting here. So simply by using the quadratic equation rule, that is discriminant method, on solving the above quadratic equation, so we have to solve the above quadratic equation to get the value of t. You have to solve the above quadratic equation. T is equal to minus b plus minus under root b square minus 4ac upon 2a, and you will get it minus 12 plus minus under root 12a square minus 4 into 4 into minus 17 upon 2 into 4, and from here we get minus 12 plus minus 144 plus 272 divided by 8, and we will get t is equal to minus 12 plus minus under root 416 upon 8, or minus 12 plus minus 20.3 upon 8, 20.3 upon 8. So we will get t is equal to minus 4.04 second, or t is equal to 1.04 second. As you know that time cannot be negative. Time cannot be negative. So we consider t is equal to 1.04 second. Time is equal to, now we have to find the velocities v1 and v2. So vt1 is equal to 12t plus 3, and it is equal to 12 into 1.04 plus 3, that is equal to 15.48 meter per second, and vt2 equal to minus 4 into 1.04 whole square plus 20, and you will get 15.67 meter per second. So this is about the velocities. Now we will discuss about the equation of motion for an object under gravity. Equation of motion for object under gravity. Equation of motion for object under gravity. So when you say that the object is under gravity, when you are throwing the object upward or the object is coming downward towards the earth, you are throwing an object above from the surface of the earth or the object is falling towards the earth, in the both the cases the motion of the object is said that it is under gravity. So when an object is thrown upwards or fall towards the earth, then its motion is called motion under gravity. Then if you are throwing it upward or it fall towards the earth, then it is called as motion under gravity. The equation of motion for motion under gravity is V is equal to U plus minus g t. Velocity time relation, h is equal to ut plus half plus minus gt square. Second, and v square equal to u square plus 2 plus minus gh. As in the equation of motion you had studied, where v is equal to u plus at, h is equal to ut plus half at square, v square minus u square is equal to 2a. Here the motion is under gravity, so acceleration is substituted by the value g, acceleration due to gravity. And there is a sign convention that for upward motion g is equal to negative. G is equal to negative because the body is deaccelerating as the motion of the object, then velocity and acceleration has opposite direction, so g is taken as negative. For downward motion g is equal to positive. Since velocity and acceleration has same direction, so here g is taken as positive, and since velocity and acceleration has opposite direction, so here g is equal to negative. So this is the sign convention we generally use while solving our questions. Now let us solve a numerical based on this. Now dear students, look at this numerical. A ball is thrown vertically upward with a velocity 20 meters per second from the top of a multi-story building. From the top of the building, a ball is thrown vertically upward. The height of the point from where the ball is thrown is 25 meters from the ground. The height of the top of the building is 25 meters. So you have to say that how high will the ball rise, means up to what distance from the top of the building, up to what distance the ball will rise, and how long will it be before the ball hits the ground, and from the top up to which the ball will rise, from there with what time the ball reach the ground. So two cases we have to consider, and I am going to solve the question. Look at the solution. First of all, I am drawing a diagram. A and B. This is the top point where the ball reaches, and after reaching here, it comes to the ground. It comes to the ground. So you have to say that how much distance it will take and what is the time to reach from here to here. First we consider vertically upward motion for the ball up to highest point to initial velocity u is equal to 20 meter per second. Final velocity v is equal to 0. Since it is the upward motion, so acceleration is equal to 10 meter per second square, and t is equal to t1. And you have to find the distance x is equal to what? X is equal to what? So v square u square plus 2ax. From here, x is equal to v square minus u square upon 2a. And since here as the ball reaches at point B, its final velocity becomes 0 minus the initial velocity, that is 20 square upon 2 into minus 10. 2 into minus 10. And it will become x is equal to minus 400 upon minus 20 meter. Means this distance will be 20 meter. X is equal to 20 meter. X is equal to 20 meter. This distance we have find. Now, second part. I have to solve the second part. From A to D, time will be t1, and from B, this point is C, suppose this point B to C, time will be t2. Velocity at point D, velocity at B is equal to 0. Velocity at B is equal to 0. Hence, V is equal to U minus GT, T1. Time for this to this we have to calculate, and it is equal to 0 is equal to 20 minus 10 T1. And from here we can calculate T1 is equal to 20 upon 2 seconds. T1 is equal to, now from the top, the ball falls freely. The ball falls freely under gravity. From top, the ball falls freely under gravity. Hence, S is equal to ut plus half gt square. Now, total distance from here to here, total distance covered by the ball is equal to 20 meter plus 25 meter. That is equal to 45 meter. 45 meter is equal to, from here at point B the ball is at rest, so initial velocity is 0 plus half into acceleration due to gravity, 10 into t2 square. T2 square. So here we can find the value of T2. It is equal to 90 is equal to 10 t2 square, or t2 square is equal to 9, or t2 is equal to 9 seconds. T2 is equal to 3 seconds. T2 square is equal to 9, so T2 is equal to 3 seconds. So T1 we have got 2 seconds and T2 we have got 3 seconds. So total time T is equal to T1 plus T2. 2 seconds plus 3 seconds, that is equal to 5 seconds. So total time taken by the ball to reach point C from the top point B is equal to 5 seconds. So this is all about today's video, students. Thank you, students. And in the next video we will discuss about stopping distance, Galileo's law, reaction time and relative velocity. Thank you for today, students. Have a nice day. Take care.